So we're going to start moving into, we finished the section of 140 where we've really building your skills. So now we're going to move into some more conceptual things that are very important in preparation for pre-cal, and really just any advanced algebra and looking ahead to calculus. And one of the really important concepts is the concept of a function. A function is a special type of relation between two sets of numbers. So this up here, for example, is a function. And the idea is that in a function, in fact, when I think of functions, I think of like a machine, actually, where the whole purpose of this machine is you plug in you drop numbers into it, and it spits out a new number. So, so every function is going to have an input and an output. The input goes in there, and the output comes out here. And so and that's why we say it's a relation between two sets of numbers. So you've seen, often we describe functions with an equation, but we can describe them with a table where we'll say, here's my input numbers, here's my output numbers. We can describe them using a graph. For example, I could graph this thing. You guys could probably graph this if I give you a little bit more time, but this is a linear equation that crosses at 2 and goes over 1 up 3. So it would look something like that. And in this way, the line is representative of all the sets of points. So for example, this point right here is represented by 0, 2. This point right here is represented by 1, 5. This point right here is represented by -1, -1. So again, you can, the idea of a function is that you are dropping numbers into it, or you're plugging numbers into it, or you're inserting a number and a new number is coming out. And so that means that those two numbers are connected or related to each other. So again, if you think about the machine, what does this machine do? This machine takes every number that you drop in and multiplies by 3 first, and then adds 2. That's what this machine does. This is the multiply by 3, add 2 machine. So if I drop a 1 in there, I multiply by 3 and get 3, add 2 to it, and a 5 comes out. And you can see that's that combination right there. So with that idea in mind, let me back up a second. I just said that the function is a special type relation. So relation is just anything that relates two sets of numbers. What's special about a function is that every number you drop in produces only one number coming out. So every input has only one output. Okay? So, and we'll talk more about that in the coming weeks, but with that in mind, knowing that this is representative, this is an equation that represents a function, sometimes we'll use what is called function notation. Function notation. So function notation means instead of a y, we write a f of x, which is just, and it doesn't mean anything different. This is the same equation. We're just making it clear that y is a function of x, or it depends on x. So just like the machine up here, what comes out depends on what I drop in, right? If I drop in a 1, a 5 comes out. If I drop in a 0, a 2 comes out. So the y value, the thing that's coming out, this is the output, and that right there is the input, right? The numbers that I replace x with are the input. The numbers that come out for y are the output. So this notation is just making it clear that the y value depends on what I plug in for x, which brings up another vocabulary word, that we have an independent variable, independent variable, which is standardly x, and then we have a dependent variable. And that is the standard one is y. Now, it doesn't have to be x and y, but usually when we have an x and y, the x is the independent variable, and the dependent. When if we have an x and y, usually the x is the independent variable and the y is the dependent variable, because y depends on x. So in this notation, all we're saying is that instead of x is my independent variable and f of x is my dependent variable. Now, another reason why we use this notation is it becomes very handy because, for example, I could just write f of 1, and that tells me something. That's saying that I plugged in 1 for x, so you can see where the x was, there's a 1 there now. And this doesn't mean f times 1. This is, if we understand we're using function notation, this means that I'm evaluating the function at 1, which means I'm plugging 1 in. My input is 1. So this is really asking a question. It's asking, what is the output? Well, when I plug in 1 for x, I get 3 times 1 plus 2. So the output would be 5. Okay, so this not only is a notation that reminds me that this is a function and that the y depends on the x, but it also makes it easy to do some shorthand questions. So I could have said, what's f of 2? Well, that again means that I'm inputting 2, what is the output? Or I'm plugging 2 into the function machine, what's coming out? So that would be, first of all, multiplied by 3, then I'd add 2 to that, so that would be 6 plus 2 is 8. So when I plug 2 in the machine, an 8 comes out. Now remember, this also means that this tells me that 1, 5 is a point on the graph, and this tells me that 2, 8 is a point on the graph. So in other words, if I wanted to graph this thing, draw a picture of it, these would be 2 of the points that would be on there, because this is telling me that the one input of 1 is connected to an output of 5, and an input of 2 is connected to an output of 8. And this notation is also handy because sometimes we might have a couple of functions we're dealing with. Like, we'll start over again and say, let's say f of x is equal to x squared plus 3, and g of x is equal to the square root of x plus 2. So I could ask you, what's f of 1? Well, because I used f, that means I'm referring to this function, not the g, right? So that means I would go up to the f function and know that now in this new context, the f is a different function now. This is a machine that when you drop a number into it, it squares it first and then adds, then adds 3. So if I plug a 1 in there, 1 squared is 1, 1 plus 3 is 4. Now I could have also asked, what's g of 1? Well, that would be a different question, wouldn't it? That means I'd plug a 1 in for x over here. So this machine, what happens to it? What happens to a number when I plug into it? First of all, it adds 2. I want to write that in this letter. First of all, it adds 2. Then it square roots. So if 1 plus 2 is 3, this would be the square root of 3. Or I could ask of some other number. I could ask, what's g of 2? Well, that means, first of all, it's the g function, so I go to the g function, plug in a 2 for x, and I get the square root of 2 plus 2, which of course is the square root of 4, which of course is 2. Okay? So when you see, for example, g of a, this will flip some of your lids, but this again is, what is this telling you to do? This says you're plugging an a into the function. Well, how do I plug an a in? Well, I just replace the x with an a. So that would look like this. Now what do I do with that? Well, we've been working a lot on simplifying expressions, right? Is there anything I can do to this to simplify? Well, the first thing I'd have to do is add a to 2, but they're not like terms. So this would be it. That's all I could do. Okay. So that's the idea of function notation. And again, the key is that you're paying attention to which function you're talking about. Is it f or g or h? We can use all kinds of different letters. And the key concept is plugging in. Now, sometimes we don't have an equation. Let's say we just have a graph. That'll be fun. So here's my graph. Isn't that a cute graph? This is the graph of h of x, okay? So then I might ask, what's h of 5? Well, notice I don't have a little machine over here I can drop the 5 into. That's what I want to do, is drop in a 5, right? But I don't know what the machine does to it. But what I do have is this little graph over here that tells me a bunch of numbers that are related to each other, right? So I need to find out which y value is related to the x value of 5. So I would go over 1, 2, 3, 4, 5, and I'd go up to here, and it looks to me like 3 is connected to 5. So that means the answer to this would be 3. Or I could say, what's h of 0? Again, this is saying when the x value is 0, or when the input value is 0, what's the output? So in the graph, that's asking when the x coordinate is 0, what is the y coordinate? Well, when the x coordinate is 0, it looks like the y coordinate is 2. Okay? Now, I could also ask the question, let's say I don't know the x value, but I know that the y value is 0. Right? So this implies the question, or actually, I guess I shouldn't imply anything. I should just ask you. You could follow up this statement with what is x, kind of, right? So knowing that the y value is 0, I could use that to find out the x value. So looking at the graph here, when is the y value 0? Well, it looks like the only time y value is 0 is right there. So what is the x value associated with that? It looks like -2. So x is equal to -2. When y is 0, x is equal to -2. So you could ask that same question with an equation. Let's say that I have g of x is equal to 3x minus 5. Okay? And then I say g of x happens to be equal to -2. Do you have any idea what x is? X equals what? Well, since this is telling me that g of x is -2, that means I just need to find an x that will make g be -2. So I just replace g of x with -2 and solve for x. So I'd add 5 to both sides and get 3 is equal to 3x. Divide both sides by 3, and I get 1 is equal to x. So when g of x is equal to -2, that means x is equal to 1. So one of the keys to function notation is realizing that you're doing function notation, because a common mistake is people see this and they think, oh, that's just h times 1. Well, no, this is function notation. It's saying what is h of 1 is the proper way to say this. H of 1, meaning that, so let's say this h of 1, which means the input value is 1, comma, what is the output value? Another way to say that is the x coordinate, if we're talking in terms of graph, x coordinate is 1. What is the y coordinate? Okay, so this is just the beginning of playing with functions, and so one of the keys is understanding this function notation. So there's homework 7 gives you a bunch of questions where it allows you to practice this idea of plugging into a function based on the function notation. So go give it a try.